This virtual course, called Guidelines for the Definition of Procedures for Disaster Prevention, Risk Assessment, Mitigation and Long-Term Management in Cultural Heritage, describes the methodology used in Heracles project for development of the operational procedures. First, about the context. In the Heracles project, we define procedures as a finite and ordered set of guidelines with the aim to improve risk management of cultural heritage in the context of long-term impacts induced by climate change. Therefore, procedures include essential risk management activities related to the long-term management of cultural heritage. Those activities are actually based on the risk assessment methodology, which was also developed within the project. The risk analysis and methodology is described in the virtual course number 3. The other main goal of establishing procedures is to help end users to use Heracles platform's functionalities because the platform implements workflows developed for the implementation of the procedures. Therefore, platform's graphical user interface specifications are embedded in the operational procedures as mandatory actions since they operate platform's functionalities. The platform is described in the virtual course number 10. Besides the procedures, recommendations for creation of reports content are also provided, and together with procedures they create a kind of operational procedures framework. However, we have to be aware that owners usually have their own procedures and documentation management systems, so some parts of the framework can only be presented in a form of recommendations in order to be easily accepted by them. The procedures linked to disasters, as they are in this context, have to be put into relation to disaster management cycle. The figure you may see on this slide shows standard disaster management cycle having 4 distinctive phases. They are preparedness, response, recovery, and mitigation and/or risk reduction. Also, according to the UNESCO, disaster management cycle for World Heritage is defined through 3 main stages that are clearly related to the disaster management cycle. The first stage is before disaster, and it is linked to risk assessment, risk prevention mitigation, and emergency preparedness. The second stage happens during the disaster, which means emergency response procedures. Finally, the third stage is one after a disaster and is related to damage assessment, treatment, such as repairs, restoration, retrofitting, and so on. However, the procedures related to long-term management in the context of climate change-induced impacts are parts of the before disaster stage, particularly prevention, risk assessment, and mitigation. Okay, since prevention and mitigation are closely related, when in practice these concepts are used interchangeably, there is a need to clearly define them. Firstly, let's see what is the aspect of disaster prevention. Well, it is directly connected to the cultural heritage resilience to the climate change impacts. And the important thing is that it is focused on hazards and consequences of impacts, while mitigation is more oriented to minimization of the impact of a disaster. Since we cannot prevent disasters to happen, the prevention phase should ensure the disaster does not result in damages or that destruction is as minimal as possible. On the other hand, regarding risk mitigation concept, it focuses on reducing the severity of hazards impact caused by a disaster. It obviously can be seen as overlapping with the prevention. However, as with other concepts in disaster management like risk, hazards, etc., both researchers and practitioners define prevention and mitigation in the context of their engagement in disaster management cycle, so it certainly may vary in practice. Herein, since Heracles project ultimate goal is to ensure cultural heritage resilience to the impacts induced by climate change, the disaster prevention concept is included in the concept of risk mitigation. The overall methodology for procedures for prevention, risk assessment, mitigation, and long term management should take into account the consistent long term strategies of climate change adaptation of cultural heritage in terms of making them as resilient as possible. And of course, the procedures should define the most feasible paths toward the fulfillment of this goal. So, basis for development of generic procedures is clear definition of the scope of the system, definition of the interrelations between key system elements, and recognition of relevant processes. In this virtual course, the methodology will be demonstrated using example of Heracles project, which means Heraklion and Gubbio test beds. Generally, these are the steps for the implementation of the methodology. The first step is analysis of a system by using an adequate system analysis tool. Then follows design of generic procedures. And since the procedures have to be validated, somehow it is necessary to set up characteristic scenarios for very concrete cultural heritage testbeds and customize generic procedures to the concrete use cases. The next step is testing the procedures using specific realistic scenarios with end users. Then results have to be analyzed in terms of technical capabilities and end users' feedback. And finally, generic procedures have to be improved accordingly. The risk analysis methodology, which is, as already mentioned, described in a virtual course number 3, is used and slightly adapted to the particularities of cultural heritage. The risk is defined as a function of vulnerability and exposure. And vulnerability is defined as a combination of vulnerability to impacts caused by different hazards. Therefore, the overall vulnerability is calculated as a function of particular ones, from 1 to n. The figure on this slide shows the generic table for calculation of vulnerabilities. Variables in column 1 represent different impacts, and after calculation they are assessed using 5 different categories in this generic example. However, this should be customized for the particular cultural heritage case. The exposure to cultural heritage to the climate change impact is evaluated by calculating the benefits of different risk management interventions for either reducing climate change impact or in case of damages due to climate change induced hazards, as defined in the presented equation of this slide. So value is a sum of direct economic value, indirect economic value, non-market value, and cultural value. The higher the social economic value, the greater cultural heritage exposure to the potential losses of revenues and maintenance costs. In the proposed methodology, we use DODAV, which is a standard system analysis method based on several types of operational views. In the project, 3 operational views are selected, which basically define sufficient basis for development of the procedures. First is a high-level operational concept, which is a starting point of the system description, providing a general overview of the main actors and activities. It is used to describe the scope of the system, identify the interactions of end users with the platform, define goals of the organization, show main information exchange channels. Herein, the high-level concept is used to generally describe how end users will use the platform's functionalities. The second operational view is organizational relationships defined by the organizational structure. Relationships usually exist between organization that manages a cultural heritage and its sub-organizations. It also maps organization positions to the platform users' roles. Usually, the organizational structure is decomposed to a degree that allows correlating specific human roles with the organization to the platform functionalities. Actually, organizational relationships are important and are depicted in operational view because they can illustrate fundamental human roles, meaning who or what type of skills is needed to conduct operational activities, as well as management relationships. And the third is operational activity model, which describes the operations usually performed by the organization aiming at achieving business goals. It describes operational activities, input and output flows between them, as well as input and output flows to and from concepts that are outside the organization. In the project, the purpose of the activity model was to define activities related to risk management, identify activities that use platform functionalities, provide basis for the validation and demonstration of the platform with respect to the project goals. This is a generic, high-level concept of the Heracles solution. It shows a general overview of the system, defining main users' roles as envisaged by the system architecture. As you may see in the figure, users interact with the platform via integrated dashboard, a special purpose user interface. The dashboard is further functionally divided into situational awareness and decision support blocks. The models to be used by experts are physically outside the platform, but the results are stored in the database, knowledge base, and accompanied reports are stored in the Alfresco software, which is a document management system. The knowledge base system helps users, namely experts, with risk assessment procedure and also helps them in cases when certain knowledge needs to be stored and used afterwards, like maintenance and remediation protocols and procedures. The platform provides full real-time warning system and workflow management support in the case a certain threat for cultural heritage asset is identified. In order to create generic organizational structure, we started with Heracles testbed. This is the organizational structure of Gubbio Cultural Heritage Authorities. Ministry has the responsibility of the cultural heritage and defines guidelines, technical regulations, criteria or models for interventions. The very bottom entities are owners of cultural heritage, no matter whether they are public or private. Ministry has local offices called superintendents which execute its decision. Their duties are to prevent negative impacts, control and maintain cultural heritage conditions, efficiency, identity, integrity, to restore or recover cultural heritage. Superintendence is in contact with owners of the cultural heritage, no matter whether they are public or private. Together, they are working on security and safety as well as conservation of cultural heritage. All intervention on cultural heritage must be authorized by the superintendents. Very similar is the organizational structure in Greece. The presented structure shows informational channels and responsibilities paths from the operational level, namely Ephorate of Antiquities of Heraklion, up to the ministry. The hierarchical structure begins at the bottom with departments of the Ephorate of Antiquities of Heraklion, which is under the General Directorate of antiquities and cultural heritage, and it is responsible for the protection and general management of the prehistoric, classical, Byzantine, and post Byzantine antiquities, which is actually situated in the prefecture of Heraklion. The Ephorate of Antiquities of Heraklion is one of the regional services of the Greek Ministry of Culture and Sports. Moreover, in parallel to the identification of organizational structures, in order to better understand and connect real situations, relations between Heracles platform's role and cultural heritage management in the project's testbed are also analyzed. The figure shows the extraction of the table for Heraklion testbed. For example, you may see the stakeholder, its subtypes, the platform's role and access rights to the platform, and what is connection to the organizational rules. As you may see, the stakeholder domain expert could be expert in archaeology, architecture, conservator, structural engineer, and so on, having a platform role and particular access rights. In the last column, you may see concrete organizational roles of domain experts for Heraklion that match platform's role structure. Based on the analysis of organizational structures of cultural heritage management in Greece and Italy, a generic organizational structure is developed. Such structure can be expected in other countries, having established cultural heritage management system under auspices of a relevant ministry. We define three main levels and generic relationships between them. On the left side, there are roles that correspond to each organizational level. The bottom level of the organizational structure is directly related to the particular cultural heritage asset, regardless the type of the ownership. If the ownership is private, the lowest level is not a part of the upper levels, which usually belong to the public body, like ministry, but is connected with them through command and control line. Namely, the public body regularly controls the private cultural heritage management. It is expected that the site manager will be employed either at the cultural heritage or at the upper management level. The position of the project manager role are someplace in the middle part of the structure, being in charge for cultural heritage in a region or a set of cultural heritage assets belonging to the same historic period. External experts collaborate with roles at lowest and middle levels. The in-situ teams are expectedly at the level of the cultural heritage asset, and an urban and regional planner, if employed within the structure, is expected to be at the middle level. The third operational view used in the methodology is the operational activity model, which includes all activities from the Heracles risk assessment methodology. Also, activities needed to run the models related to hazards or cultural heritage health, like structural models or material analysis, diagnostic and systemic protocols, as well as platforms functionalities, which are supposed to support the long-term risk management of cultural heritage in relation to climate change. The activity model is developed in business process modeling notation. The reason for this is because the notation can be easily converted into XML code for the implementation in the Heracles platform. The whole cultural heritage resilience approach is based on a combination of risk assessment methodology and results from analysis of climate change modeling. By using climate change modeling results for the future state of the atmospheric conditions as input data for models, hydrodynamic, landslides, etc., thus obtaining future magnitude of climate change induced impacts on cultural heritage. Like, for example, wave heights in Heraklion, which may damage cultural heritage assets in the future due to change of wind strength or salinity in the air. So we may see what could happen in the future to cultural heritage assets. Then calculate the amount of risk and act now by planning and implementing mitigation actions to prevent future magnitude of climate change induced impacts on cultural heritage. Here you may see the list of the principal workflows which creates activity model. There are risk management as a principal workflow, threat identification and threat assessment. Uh, this is those activities are quite crucial in the methodology since certain situations or circumstances may lead to damages of the cultural heritage asset and future impacts induced by climate change. Such situations or circumstances suddenly spotted during the monitoring or even analyzed during long periods are defined as threats and have to be analyzed, and if proven significant, the risk has to be assessed. Then there is a vulnerability assessment and exposure assessment as a part of a risk assessment activity. Running models, which are necessary models for understanding climate change induced impacts. Running CC model workflow is actually an activity related to the analysis of cultural heritage modeling results if needed. Cultural heritage health analysis necessary for understanding the state of cultural heritage asset. Contacting all experts as a part of a cultural heritage risk management process, and final risk mitigation related to creation of mitigation plans to avoid deterioration of cultural heritage in case of future climate change induced impacts forecasted with the help of climate change modeling results. Here is the main workflow, risk management, presented in a business process modeling notation. The workflow starts with three options. Firstly, with monitoring when something is spotted on site, like damage on cultural heritage assets, which has to be immediately reported. Then on demand because some analysis pointed out to severe deterioration of the asset, and there can be a need for new analysis of climate change modeling data because of severe changes in weather patterns, or the analysis has been performed long time ago and risk assessment has to be done again. All paths go through the same threat identification process. At certain point, site manager can decide whether to go with new analysis of climate change modeling data no matter of the starting point. And the whole process ends with risk mitigation. Monitoring may end immediately if the spotted signs are not relevant. Here is another example of a workflow. This is risk assessment workflow. And on the left side, you may see the actors of the activities. If the threat is identified as significant, then a site manager sends a request for the risk assessment. The risk assessment procedure starts with the vulnerability and exposure assessments in parallel, performed by selected experts. Then follows risk estimation, and then the reports and results go to site manager for decision to be made. Site manager checks the report on risk assessment, updates information, and proceeds with risk mitigation planning if necessary, namely if the risk really exists. After the analysis of the system, organizational structures and activities, operational procedures development may start. The development in the Heracles project was based on the following structures. Operational views as a basis for the development of the procedures, then diagnostic protocols for maintenance of a cultural heritage also developed within the project. Of course, the main architecture of the platform, in principle, platform's graphical user interface, and knowledge base architecture and functions. And finally, as already elaborated, it was the Heracles risk assessment methodology and also Heracles methodologies for maintenance, conservation, and restoration also developed within the Heracles project. Besides the operational procedures, which mostly end with reports, we also decided to develop recommendations for contents of reports, textual parts and messages, thus creating a kind of operational procedures framework. The first picture shows a small portion of operational procedures with related activity, precedent activity, who is responsible for the procedure, this is the actor column, and how they are supported by the Heracles platform, this is in the last column. In this extraction, it is a domain expert who performs the procedures, and the platform functionalities are workflow and document management system and knowledge base. The second figure shows an extraction of the recommended content of the documents and reports. In this particular case, it is extraction from threat assessment report showing an example of a threat assessment table, as a threat is in proposed methodology calculated by a combination of cultural heritage health and threat hazard impact. The next step is validation of operational procedures framework, and it has to be performed through the following steps. Firstly, development of scenarios for test beds, which simulate real situations by finding realistic and the most expected climate change-induced impacts. It is also important to cover distinct paths of the risk management workflow and to include main activities such as threat identification and assessment, risk assessment, as well as set of risk mitigation actions and measures to avoid impacts from identified future hazards. The developed generic operational procedures has to be customized to meet the needs of test beds. Then the end users test the operational procedures by using prepared scenarios and platform. And the final step is the analysis of the end user's reflections, and based on this analysis, the improvements of generic operational procedures framework. So, scenarios development process started with identification of two distinct paths in the workflows and their association with project test beds. Threat identification path of the scenario for the coolest fortress starts from the monitoring, goes through identification process, identifies significant threats, and then through the path with activation of a new climate change modeling analysis. On the other hand, threat identification paths for the scenario of the Palace of Knossos and Consoli Palace and the Old Town Walls in Gubbio starts with the risk assessment on demand, goes through identification process, identifies significant threat, and then through the path without activation of a new climate change modeling analysis. In order to get feedback from end users after the validation process, in the Heracles project, a questionnaire was prepared. It is structured into sections. The first part contains questions related to the operational procedures' usefulness and appropriateness for cultural heritage long-term risk and resilience management, like overall efficacy and efficiency, appropriateness of cultural heritage long-term risk and resilience management. Do the operational procedure fit into end users' common cultural heritage management processes? Procedure appropriateness for other scenarios and other kinds of cultural heritage in Europe. Also, end users were asked to name eventual missing processes. The second part of questions are related to the implementation of operational procedures in the platform, like was it easy to follow the operational procedures in the platform? About graphical user interface compliance with operational procedures, and do the platform cover operational procedure steps, and so on. Operational procedures framework testing and validation in the Heracles project was performed in two steps. Firstly, the dry run was performed, which means testing of harmonization of the operational procedures and platform's functionalities. 4 scenarios were technically tested without presence of end users to be sure that the platform fully supports workflows. After the dry run, a validation with the presence of end users was performed, and after the exercise, end users from Gubbio and Heraklion filled the questionnaire. On the slide, you may see the extraction of the analysis of end user suggestions after the validation. The suggestions were taken into account and the operational procedures framework was improved. What could be follow-up activities and challenges after the implementation of the methodology in the Heracles project? Well, certainly further improvements may go towards more flexibility of the structure to be more implementable in a certain particular cases. Also finding more concepts from ever-emerging standards or similar documents that are related to resilience of cultural heritage in general, and then expanding the framework towards other phases in disaster management cycle could be very challenging. And usually when dealing with procedures, the challenge is also the ambition towards standardization of the cultural heritage resilience assessment and management practice related to climate change induced impacts, but not limited. And in this context, this proposed framework could be a good basis.